All right. Ready to party. Hey, if you're this is your first time here, welcome to the stream. Today we're working on Game Dev Bootcamp. This is part of an 8-week series that is now 7 weeks, but hey, who's counting, right? We're still going to cover all the content though. I've trimmed it down a little bit just to make sure that we can get everything into this final stream, but essentially just wanted to try to close things out a little bit early, take next weekend off to kind of regroup. So doing these weekly streams, it's been a lot, but I'm happy to do it. I'm happy to, I've learned a ton doing a live streamed course. I think in the future, knowing what to do differently, definitely can make some improvements going forward. But hopefully people are enjoying the course. I've gotten fairly good feedback so far. Really the only negative feedback, which I feel myself, is that it's a little bit more rushed. It feels a little bit more fast paced, which for a beginner might be hard to keep up with. So yeah, and I'm gonna shut this music off. That way we can focus on the content. So real quick, I want to do a couple things, get them out of the way. That way we don't have to talk about it. But creating this content, it does take a lot of time. I am committed to keeping this content free. I will continue to make free content for this channel. I don't make any money off of it yet, but one way you can help support the channel is by booking a 60-minute mentoring/tutoring session with me. This is 60 minutes to talk about whatever you want. We can go over your project goals, go over your career goals. I can give you tips and tricks on how to get into the game industry, or how to build your resume, how to build your portfolio, or if you're working on a solo project and you just want some help, we can go over, ways that you can get your project working. So really, this is about anything. Even if you just want to talk about games and game dev for an hour, this is a way you can help support help support the channel. $25 for an hour isn't bad. If you do some research, this is about half the going rate. So I will probably be increasing the price of this at some point. So make sure you get it while it's still $25. You can scan the QR code, or you can go to my website, jimdouglas.com. There's a page for book services. You can book the 60-minute session there. And your audio cut out? Huh. That's weird. It's not. What about now? Is that better? Dang. Just talking to myself over here. Oh, it was fine. All right. Weird. It's back. All right. Great. Thanks. Thanks for the tip. I would hate to just talk to dead air. So yeah, book a session. Let's talk. Anyway, I also have some merch. So I know this might be a little weird. I'm not like, but I did have this idea for Dev Every Day. This is a way that I bought one of these mugs for myself actually. And just a reminder, every day making progress. There's also Jim Douglas merch as well. Hey, it's cheesy, but it's a way you can also help support the channel. You get something in return, which is something that I don't want this to be a situation where I'm just asking for people to give me money. I would like people to get something in return. So there's stickers, mugs, shirts, tote bags, whatever you want. So buy some merch, support the channel. So originally we were gonna do week 8 next week. I was going through the content, and I really think that there's probably We could probably squeeze in the rest of this today. So I just compressed everything down. We're going to be doing week 7 and weeks 8 today. I might actually end the stream and then start a new stream for week 8, just so that there's like a clear delineation between the 2 weeks. But we'll see. We'll see how it's going. So we're going to get through weeks 7 and 8 today. Week 7. So last week, if you were watching, we did an introduction to C++. We built some basic things in C++. And today we're going to keep building on that knowledge. So we're gonna show how to use blueprints and C++ together. People ask all the time, like, which one should I use? The answer is both. But I'll show you some of my personal preferences on how to do this, and we'll build a couple classes in our game that show the power of using them together. Hopefully I get my point across with that, because it really is a cool system once you understand how to utilize both together. And then the final week of the course is just about all the stuff that we want to do to launch our games. So we'll go over that after we get through the week 7 content. And yeah, so that's that. Let's get going. So also, if you were watching the stream last week, I did encounter an error like right at the end of the stream, and I was like a little bit burnout, so I just didn't have the patience to fix it on stream. So off stream, I did end up getting the fix. So essentially, in our C++ class for our interact component, I think we had this function where we're trying to use the camera and we're trying to create a line trace into the world. And so it needs to get the camera. So you could either like up here, get the camera of the actor. What I did is just take my interact component that's on my player character. So this is the only change I've made to the project since we left off. And then I want to get that camera, or set the camera on the interact component. So if we look here, there's this camera. Now we can't set it to anything. So if you do it this way, take your follow camera, which is this one that's on the player, and we want to set the value of camera on our interact component to follow camera. And that fixes that error that was crashing the game that we encountered at the end. So other than that, the only other thing I did was I hooked up this, I created this little dot in the center so we could see like where that line trace is without actually having to draw the line trace, so to give the player an indication. And then this up here is just some debug stuff that I'm doing, and all it's doing is just getting the interacting actor and setting it so that when I play, as it's interacting with something in the world, it will just tell me like, what am I interacting with? And notice it's not interacting with that because it's probably not got the right collision channel set on it. Let's see here. Collision, visibility. Oh, I think it needs to be block. For this one maybe, or which one are we using? The visibility channel. So it needs to be that. We can try this. Now we should be able to interact with that health potion. Yep, there we go, health potion. So that's working. So that's really all we've done. That's all I did on this project since we left off. So let's go into week 7. So this is week 7, lesson 1, guidelines for class structure. In this lesson, I'm going to review the benefits and disadvantages of C++ and blueprints. Then I'm going to give you some of my own personal tips on how to structure your classes. I'll give you a hint. It's up to you. Like it really is it's so situational. So when people ask like which one should I use, Blueprints or C++, the answer, like, it's so cliche, but it depends, right? So let's talk about this. So we've been learning a lot about Blueprints. We barely scratched the surface on C++ last week. I think the goal would be, if you're watching this course, to continue your learning in C++. There's plenty of great tutorials out there, and we'll discuss some of those when we get to the end of the course. So these are just some pros and cons of each of them, and you'll notice that they kind of are like the reverse of each other. So they're really meant to balance each other. So C++, the pros, it's optimized for performance. We learned that this was basically a programming language that was developed for like very large and complex systems with lots of moving parts and asynchronous functions happening. So it's ideal for game dev because of the optimization of it. It gives you more control over the code base. So writing stuff in C++, you can literally just write whatever you want, and there's no like real guidelines to it. It's just make it work, whatever you want to work. There is, sorry. You can also integrate external libraries. So if you have something that's not currently in C++, you could just drop it in and make it work. Yes. Why is... All right. I'm just going to stop for a second. I'm going to check on the audio of this stream. Oh, there's no audio. All right. Audio issues. All right. Apparently it's working. Don't really understand. All right. Let's I'm just going to check real quick. All right. Sorry. What a mess. Man, one of these days I'm going to learn how to be a streamer. Anyway. Yeah, I don't really understand what's going on with this audio. But let's turn the music back off. That way we can focus on the lesson at hand. Hey, if you're watching and you can't hear me, let me know so I can fix it. I'm actually going to do this. All right. Sounds like it's working. Oh. All right, we're off to a great start. 15 minutes in, and we've gotten into 2 slides. All right. So one of the cons of C++ is that it has it's a little bit slower to develop. I think I've already shown that it's like a lot of downtime waiting for things to compile. You gotta close out Unreal Engine to make your changes, and then reopen it, which takes some time. Which comes down to the next one, higher skill level. So a lot of times if you're learning, it's going to be tough to program in C++ because that learning environment of like changing something, seeing what happens before you've like built this like knowledge base of things that work. It's gonna take you a lot of time to learn. Where Blueprints, you can pick it up fairly quickly. A lot of people that have no experience in coding can understand the visual scripting a lot easier. It also requires a lot more discipline. If you change something in C++, it could break your game. So as you saw, that error that we created last week was literally crashing the game. So there's no real guidelines, whereas with Blueprints, a lot of times if something's not working, it'll just give you an error. It'll give you some information on what's happening. That's not necessarily built into C++. So some of the benefits of Blueprints allows for rapid development, so you can iterate things very quickly, try things out, change things, see what's working. It requires a lower skill level to at least to begin. You can pick it up pretty quickly. I would argue, like, as things get complex, you're going to need a skill level in either. But at least in the beginning, most people can pick up Blueprints faster than C++, especially if you don't have a programming background. There's controls in place to prevent undesired outcomes. So it's a lot of times Epic has programmed it in a way that you kind of can't break it in Blueprints. You could still definitely cause like infinite loops and things like that, but it's for the most part not going to crash your game. They put a lot of controls in place. It's not the best optimized solution. So, I mean, it's gotten better over the years. I will say, like, there's probably a negligible difference in most cases between Blueprints and C++, but really heavy, like, functions that have a lot going on in them, you will see a difference between C++ and Blueprints, but not. I mean, it's not the end of the world, right? If you're working at a AAA company and you're making like Call of Duty, sure. But like for most indie devs, probably not going to notice a difference. Less control over the code base, so you kind of have to work within the constraints of what Unreal Engine gives you or what you program for yourself. And you must work within the constraints of existing nodes unless you build them in C++. So this is where, ultimately, the idea is that they work together. So yes, you won't have access to all the nodes in Blueprints, but if you use C++, you can make whatever nodes you want. But really the idea is not one or the other. Unreal Engine is meant to use both. So you should understand both and you should use both for your projects. So how do you draw the line, right? How do you decide whether something should be a Blueprint or whether something should be C++? How do you establish that? And really there's not like a rule. These are just my tips. So this is my personal opinion. So first tip, don't reinvent systems that are already in place. If something already exists in Blueprints or in C++, you don't need to rewrite it, right? So like the damage handling functions where you can use the apply damage and take damage or any damage events and functions, or I think it's technically a dispatcher. There's not really a reason to reinvent that. It already exists, so just use the one that's already there, right? The next tip is use what works for you and your team. So each team is going to have their own guidelines based upon the skill level. If you're not as comfortable in C++, don't like go out of your way trying to like make things work in C++. If you just want to like continue developing games and you just want to have fun and you're not worried about optimization, you're not worried about like working in a team environment and like object-oriented programming principles, you just want to make fun games, just use Blueprints. Like no one's No one's going to care that much, right? Use what works best for the project. So each project is going to be different. If you have like a pretty simple casual game that optimization isn't a big deal, like I think of like turn-based games where like you don't really care about milliseconds and ping, it's more about just like, does the game work? Sure, like just use blueprints. Or if you have a game that's super complex, you have things where you want, to encapsulate functions and do all of that. I mean, you could do some of that in blueprints anyway, but it really just comes down to your team and the project that you're working on. This next tip is one that I think is really important. C++, yes, will be faster than blueprints. I'm not going to argue that. But bad C++ is going to be slower than well-written blueprints code. Bad code is bad code. So at the end of the day, if you're worried about optimization, really you should just focus on writing good code. And for the most part, you won't see like that big of a difference. Which brings me to my next point. For most games and features, I would say like 90 to 95% of stuff that you program, you will actually not see a difference between blueprints and C++. Like we're talking about like tenths of milliseconds probably difference in most cases. Now that does stack up, right? So if you have like a lot of those, then you will see it over time. But for the most part, for most casual games, most indie games, you're not going to see a big difference, honestly. It really just comes down to you. The last point is one that I put in there because it's something that I personally have gotten like way too comfortable with blueprints. A lot of the projects I've worked on have been just about like iterating something quickly, like get something working, prototyping, creating quick demos, things like that. So I've like gotten very comfortable in blueprints, and C++ is not. I struggle with it. Like it's very slow to me. Takes me a lot of time. I have to remember how to do things. I have to watch a lot more tutorials because I'm like, how do you declare this type of variable, and like what, like is this a pointer? Is it not a pointer? Like all of those things. I struggle. So like I even like struggled teaching C++ for this course last week because it's not something I'm like super comfortable with. And I did a ton of research just to make sure I was giving good information. But my point in all this is really you should be challenging yourself. So once you've learned a little C++, like try to keep working on it. Try to keep building it into your projects. At the very least, declare your classes as C++ classes. Declare whatever functions you can. You may reach a skill level gap. Try to fill those over time. But it's just, I think it's important, like as a game developer, that you're constantly challenging yourself and pushing yourself. And I personally have gotten way too comfortable in blueprints, and now I struggle with C++. So, and hey, if there's an audio issue, let me know, because I was having audio issues earlier. If someone could let me know, that would be helpful. So I also want to put some like considerations in here. So the first consideration is the goal of this course was to teach a variety of topics like in a short timeline. So I compressed as much as I could into 8 weeks, which means some of the things that I did were chosen for educational purposes. So they're not like, I haven't always shown like the way that I would do something for like a full-fledged game. Some of the times I made a choice based upon like, I just want to show something, I want to teach something, so let's squeeze it into the game. And then another thing is, as games get more and more complex, there's almost always going to be more than one way to do something. There typically is no right or wrong way to do something. I see this a lot, like what's the best way to do something? So it's not about right and wrong, it's about, can you do it better? Is there a cleaner way? Is there a better implementation of something? So those are the types of things, like when you're programming, you shouldn't be worried about so much about right or wrong. Just worry about like, does it work? Get it working, and then how do you make it better? That's the way I look at it. So, and that's one of the things, when I'm programming, I always ask myself, is there a better way to do this? So the way I typically program things is like, just get it working, prove that it works, and then once it works, then I'll start to refactor, I'll sort of change things around and try to find better ways to do something. So always ask yourself, is there a better way to do this? And that's the end of that lesson. So let's head to the next lesson. This is going to be week 7, lesson 2, player leveling system. So in this lesson, we're going to define our requirements for a player leveling system. Then we're going to learn about curve variables. I'll show you what that is and how to use one. And then we want to create a leveling system component and then create any supplementary functions and variables we need to make it work. So a lot of times people ask, like, when they're just starting out, like, how do I get started with something? So one of the things that I like to do is I like to define my classes ahead of time before I ever even write a line of code. So this is a format that I like to use. You can use it if you want. I also keep like 3x5 cards at my desk, so I can do this on paper. And a lot of times if I'm just starting out a game, I'll just get like a stack of these and just start writing out everything I want in the game, and just kind of like lay out the game in a way that like I can kind of absorb everything. So I'll define each card as a class. I'll write out what variables, what functions, are there any interfaces needed? Are there any delegates? Are there any other things? Like how do the classes talk to each other? What is in each of these functions? So like, what is a level up function? What is a gain experience function? Define my variable types. So this is the way I like to do it. Feel free to try it, see if it works for you. But essentially, like, what you're trying to do is minimize the back and forth. So you, like, obviously with a leveling system, we need an integer called level, and we probably need an integer called current experience. But how do we keep track of what level we are? How do we keep track of when the player will level up? All of these things are things that you want to like try to think through before you start to program, because then you may get into a situation where you're like, oh, I need a new function, and then maybe that requires you to like rewrite some code. So it's just more efficient, I think, to just write out everything you need. So here's the ones that I came up with. Current leveling system, or current level as an integer, current experience as an integer, a level calculation, which I'm going to use a curve variable for that, and I'll show you what that is. We want a function to level up, right? That's a big part of a leveling system. We want to be able to level up. We want the ability to gain experience, so we want to pass in amount of experience gained and have the player be able to gain that experience. I couldn't think of any interfaces for this, so we can leave that one off. And then, I mean, there probably could be if you really broke things down a little bit better. And then there is going to be a delegate called onLevelUp, but we're going to build that in the next lesson when we build our stats, because when we level up, we want to send a message to our stat system to increase all the stats. So let's talk about this curve variable type that I talked through. So there is a class called a float curve. It allows you to implement curves, so we can actually create a graph, and we can have the x-axis is called time, and the y-axis is called value. And there's some functions that we can use, so we can get float value, so we can input a time, which in this case is going to be experience, and it will return a float of the value, which in this case will be the level. So we can pass in the number of experience that we have, and it will return what level we should be at. So get time range returns the values on the x-axis, so we can get the low point and the high point of that curve. Get value range returns the range of values on the x-axis, so we can get the lowest level, which in this case would be 1, and the highest level, which in this case we'll set it to 30. So we're going to cap our level at 30. So let's create our level system component. I'm here in Unreal Engine, and I just want to create a new C++ class. It's going to be an actor component, and it's going to be public, and I'm going to call this leveling. Let's call it leveling component, just to make sure that we know what it is. And I'll create my new class. Hello, Siren. All right, there we go. We're almost done. All right, so that's good. We want to go here, reload all. Yes. All right, let's close out some of this stuff. All right. And I'm gonna get my cheat sheet up over here. So let's start out. If we go back to this, let's declare some of these variables. So let's start by declaring a current level. And I'm going to put this in the public. So we want a new U property. And this is going to be int level. Let's call it current level. Another U property called int 32 current experience. And then I want to create another variable that's going to keep track of that float curve that we talked about. So I can do a new, and it's going to be of type U curve float. And it's going to be a pointer called experience curve. Now for this, we will need to include the include file for this. So let's do that. So the include file is curves/curvefloat.h. And this is what will allow me to utilize this experience curve. And let's actually declare that. So here in my constructor, I'm just going to do experience curve equals null pointer. And let's save all. Oh man, sometimes save all gets angry. All right, I'm gonna do a build, and we shouldn't have any build errors because this is pretty straightforward. All right, everything is good. Let's go ahead and launch our game. All right, there we go. And I'm going to go to character. I'm going to go to blueprints, characters. And on my player character, I want to implement this leveling component. And there we go. Now we have our leveling component. And we can see that we have our current level is 0, our current experience is 0, and our experience curve is here, but we don't have a variable type. So let's go ahead and talk about how to build that. I'm going to create a new variable, and it's going to be of type, I can never find it, curve. All right, so we can create a new curve, and it's going to be of curve float, because that's the type that we declared. And let's call this, I don't know the prefix for curve. All right, we'll just call it experience curve. And let's open this up and let's see what it looks like. So here we have, a curve essentially, and we can right click and add key. And up here we can set the variable. So if we consider that we want when the player has 0 experience, and experience is going to be on the x-axis, they're at level 1, which is going to be on the y-axis. So let's set our first point to 0 and 1. All right, so now when we have 0 experience, we'll be at level 1. But what we want is that when we have, let's call it 10,000 experience, so I'm going to click here, and with this one selected, when we have 10,000 experience, so that's going to be on the x-axis, we want to be at level 30. And if we, which one of these does it? It's one of these will show the whole. Oh, here we go. Zoom to fit. Zoom. There we go. Now we can see our whole graph. And we don't want this to be linear. I mean, what you want typically in an RPG is to be able to get some early levels fast, and then it's much harder to get to that final level. So we can right click on one of these points and just set it to break, and then we can actually drag this, and what we want is that to have a curve that kind of looks something like this. So essentially what we can do is we can look here that at about 120-ish experience, we're going to hit level 2. And then at about 230, we're going to hit level 3. About 360, we'll hit level 4. And essentially we'll get those early levels much quicker, but to get from 29, let's find 29. 29 is going to be at 67.22, but to get to 30, we got to get 10,000, right? So basically the point being, early levels are going to come fast, and then as time goes on, it's going to get much harder to level up, which is typically what you want with an RPG, right? Every RPG I've ever played is like that. So now we can use that experience curve as the variable for this, all right? So let's do our next piece. I'm going to save all, and now that we have that, we want to be able to program to gain some experience. So let's do that. I'm going to close Unreal Engine. I'm going to go back to my header file, and here I don't think it really matters, but I'll put it down here. This can go up with the rest of the public. I don't know why we need two different public sections. And this can be private. So let's declare a U function. It's going to be blueprint why do you feel the need to do this? Blueprint callable, and it's going to be, we're going to use a meta tag, allow private equals true. What is that? And we want this to be a void gain experience, and we'll pass in a variable of experience. So let's right click and let's where's my little wrench screwdriver, let's declare the definition of this. Gain experience. Oh my goodness. So we want to say current experience equals F math clamp This is working. So current experience plus experience, the experience that we passed in, and we're clamping it between 0 and 10,000. So we can't get negative experience, and we can't get more than 10,000 experience. So when we hit 10,000 experience, we're going to level up to level 30, and then that's it. No more experience. And then we want to check our experience curve. So if experience curve we'll call this float curve value. Great job. If curve value is greater than or equal to current level. And for now, we're just going to say level up. And let me just talk through what's going on here. So now that we have this written, I can kind of break it down. So when we gain experience, which we're going to pass in a number of experience, we're going to set our current experience to whatever the current experience is plus the experience that we've passed in. And we're going to clamp this between 0 and 10,000. So that's the first part of it. Then we want to check if, well, first of all, we want to make sure that our experience curve exists. So this is kind of like an is valid check. It's basically checking that the experience curve has a curve, because if it doesn't, we're going to break the game. So if it doesn't, then it'll just do nothing. But if it does, then we want to set a local variable of curve value, and curve value is going to be experience curve, and then this arrow means on this experience curve, call a function called get float value, which we're going to pass in the current experience. So remember when we were in here, this get float value, so we can pass in an x value, which is the number of experience, and it's going to return a y value, the level. So we're going to pass in the amount of experience that we have, and it's going to return the level that we should be based upon the level that we are, the amount of experience that we have. And then we're going to check if that y value is greater than or equal to our current level up. I guess we don't need the equal to. I think we just use the greater than, because otherwise it's going to call it every time we gain, and that's probably not good. So now we need to write this function called level up. So let's save all. Let's go back here. And let's write another function. This one's going to be let's just grab all this. GitHub Copilot is great, but sometimes it can be really annoying. Level up. And we want to pass in an int 32 called new level. All right, and what's going to be on this one? Current level equal to, oh man, what did I do? Why didn't it pass that in? New level up, int 32 new level. Level up, int 32 new level. So current level equals new level. All right. That's actually going to be the leveling up part. And that's it. That'll level it up. So let's check that this works. Save all. I'm going to do a build. Let's launch our game. All right, we got it. Let's open up our character. And just to show that this is working, I'm going to use the tick function just briefly. So let's type tick. Let's get our event tick. And then we'll get our leveling, say gain experience. And I'm just going to have it pass in 10 experience. And I want to do a print string of current level. And just so there's not a million of these, let's set key 1. So we're printing 0, and it's 0 still. All right, what do we do wrong? So the experience is going up, it's just not leveling. Let's do this. All right, something's up. Let's look here in my secondary project. Leveling. So the experience is going up, but we're not leveling up. Why is that? Oh. That's a good reason why. Let's see if we can hot compile this, save us some time. I have notoriously bad luck with hot compiling. Perfect. All right, it's working now. Check this out. So we're printing the value, and then we can see that our levels are slowly going up. $30. Done. All right, so that's working. And we can add some stuff on our UI to show this as well. So what's this one? That's our health. Let's create another text block. Let's bind this to, let's create a binding. I want this to be get player, get leveling, get current level, string, append, level, whatever. Right? So level 2, 3, 4, 5, it's going up. All right, let's get rid of that print string. And I'm going to keep this in here for now because I want to, what I would actually like is an XP bar that keeps track of how much experience I need, right? And for that, there are like those functions that we had, but really I would like to do some math and have it figure out how much experience we required to get to our our current level, and how much experience was required to get to our next level. And we could do this all in blueprints, but I would actually like it to be done through C++, and I would like those to be variables on the leveling component. That way we don't have to do the calculation every time. We basically do the calculation when we level up, and then we set those variables, and then they're just set, and then we can draw from them. Because otherwise, I mean, I can create an experience bar that does the math, and then every time we need that information, we can do the math, but I just think it's a little bit more efficient to do it this way. So let's save all. Where are we at? We're at an hour, so I think we're okay. Let's close this out. And in my leveling component, I want it to create 2 new variables. And we'll put them up here. So the first one is going to be a float, and this is going to be called required experience current. So we want to see how much experience would be required to get to the current level. And then I'm going to declare another variable float called required experience next. And these will look at how much experience we need to have the current level, and then how much experience we needed to get to the next level. And let's look at how we do this. So on begin play, I actually just want to set these right off the bat. So I'm going to say required experience current equals and we need to do a calculation. So I'm going to create another function that can do this calculation for us. And it's going to be ufunction and it's going to be called it's going to return an int. I'm sorry, I need to use my cheat sheet. Calculate required experience, and it's going to take an input of a integer called level. Look at you. You already know what to do. All right. Now, to look at the float curve, we're going to have to do a few things. We're going to call float min. We're going to create these local variables. And then we're going to say if experience curve, didn't want all that, if not experience curve, if not experience curve, and for this there's actually we could just call return 0, and this is like a quick thing that if there's no experience curve, just return 0. This is just to prevent our program from crashing. The next line is going to be to get that experience curve and get time range of min and max. And then for float I equals min semicolon I greater than max semicolon plus plus. Okay, that is not what I want. So this is how a for loop works in C++. We're going to call the for loop. We're going to say for the beginning I equals min, and then we want to, this is our until, like what's the next statement. So as long as I is less than max, we want to keep doing this, and then I plus plus. So I equals min, as long as I is less than max, then we'll keep doing this, and then I plus plus. So now, if I really need to turn off GitHub, experience curve get float value I is greater than or equal to level break. Return experience. Oh. I missed a part. Experience required equals 0. It's a float. I think that's it. All right. That's a lot, right? Let's see if we could zoom this in a bit. I'm going to make this make sense. I'm going to break it down, hopefully. So we're going to call this we want this calculate experience required function because we want to understand how much experience is required to get to a level. So we're going to take in a level and we're going to return the experience required to get to that level. So if I pass in 1, it's going to return the experience required to get to level 1. If I pass in 14, it's going to return the amount of experience required to get to level 14. And we are going to use this to set up basically an XP bar. Like all of this is just to set up an XP bar. But we're doing the calculations in C++, and that way it'll be a little bit more efficient. We could do this in blueprints, but yeah. So we're going to set 2 local variables, max and min. We're going to check if we have an experience curve. We could probably even put this up above here. That way we just stop immediately if there's no experience curve. Matter of fact, let's do that. That way all of our local variables are together. All right, so we're going to set a min and a max, but they don't have any values in there. Then we're going to set an experience required. It's going to be a float, and we're going to set that to 0. Then we are going to use this function called get time range min max. So it's going to this is actually this is a weird function. It looks like a get function, but what it's actually doing is it's taking our experience curve it's getting the minimum experience on the X and the maximum experience on the X, but it's deceiving. This is actually setting min and max to those values. So after this, min will be set to whatever the lowest X point is, and max will be set to whatever the highest X point is. So even though it says get time range, it's actually setting these variables that we declared. It's setting a value. I know it looked weird to me, but I promise you that's what it's doing. You can hold control and click and look at it, and it will tell you basically what I just told you. All right, and then we want to do a for loop, and this for loop is going to set I to whatever the minimum value is, and then it's going to check as long as I is less than the maximum value, we're going to increment I. Then we'll set experience required to I. So every time this for loop fires, we're going to be setting that to whatever the experience required is. Then if at any point the I returns a value that's greater than or equal to level, the level that we passed in. So it's going to be going through the experience curve, and it's going to be checking. All right, I have 1 experience. What's my level? I have 2 experience. What's my level? If at any point it gets to the number in that experience curve of the level that we pass in, then it's going to stop. It's going to stop this for loop. So whatever the last value that we set here to I becomes the experience required to get to that level. And then we will return the experience required to get to that level. That was a lot. I hope that makes sense. If it doesn't, you can ask me in the comments. You can ask me on Discord. I promise it. I promise it does what I said. So essentially, all of this is to pass in a level, and we're going to return the experience required to get to that level. So all of that was to do this. Required experience next. So on begin play, we're going to look at whatever our current level is, and we're going to set required experience current, that variable we declared, to how much level it takes to get to the current level. And then required experience next will be calculate experience to get to the next level. And this will allow us to create that XP bar. And then we want to grab these and copy them, and I'm also going to paste them into my level up function, so that every time we level up, it's going to recalculate. I'm pretty sure that's all we needed. Let's save this, let's do a build, and then we'll go back to Unreal Engine. All right, no issues. We're almost done with this. I think this is actually the last step, and then we're going to make a stats component. The stats component will be able to hold whatever stats we want. All right. Let's open up our character. So actually, I want this to continue returning level. I want this to move up a little bit. I also want to create a progress bar. Let's anchor this to the bottom. Make it like a little bit skinny and long. 220. Let's go 300. And let's see if we can get this working. So let's, I'm gonna make it purple. I don't know why. I feel like experience bars should be purple. Because it's like a color that's not used for other things, right? You can make it whatever color you want though. Let's bind this percentage. I'm gonna create a binding. I want to do my player, and I want to get leveling, and I want to get experience required current, get get required experience next. Nope. Let's divide these. Is that all we had to do? I think there's another step. Yes, there is. Current experience. This actually will return nonsense. All right. So we want to subtract this. These should be switched. All right, so we're going to get our current experience. We're going to subtract the experience required current. So if the required experience to get to the next level is 100 and we have 120 experience, it's going to give us 20, right? Then we're going to subtract experience required next. So if the required experience to get to the next level is 250 and we subtract the required experience to get to the current level, which was 100, then we'll get 150, and then we'll end up with 20 and 150 and create a percentage of that. So the idea is, if I did everything correctly, yep, there we go. That experience bar is now filling up. We'll notice it's going to start slowing down as we get to the higher levels. And then it will stop at 30. Kind of. So yeah, that's working. We have an XP bar. We did it. We now have a leveling component that is 100% modular. We could throw this onto any actor in the game and just call this one function to gain experience, and it works completely independent of anything else. So now that that's working, let's save all, and let's talk about some stats. Let's create a stats component. And for this, we have another lesson. But I do think I'm just going to take a quick break. So just a couple minutes and I'll be right back. All right. I found it's like good when I'm doing these long streams to just get up every once in a while, move around, get some water. So this is week 7, lesson 3. And what are we going to do in this one? We're going to make a stat system. So this is common to like most RPGs. You get a level, your stats increase, and they maybe increase based upon some curve. So we're going to, in this lesson, we'll define our player stat system requirements. We're going to use another new variable type called a curve table. We're going to create our stat component, and then we're going to actually create that delegate for our on level up so that when we gain a level, we can increase all the stats. So again, using that same format, I want some variables. I'm going to declare this. You can declare this as a struct. You can declare this as just individual variables on the stat system. I think that's how I'll do it, just to avoid having to learn about structs in this. Maybe we'll do that in a future like lesson or something. We want to have a function called gainStat. We have no interfaces for this, and then as I said, we're going to have that delegate from our previous one called onLevelUp. We're going to bind to that delegate. So with delegates, remember it's a one-way message that we're going to broadcast from one actor, and then any actor that's listening can do some functionality. So we can bind to that onLevelUp will gain all of our stats. So you can do this differently for your game. I just want to show like a variety of stats. So we'll create health points. We already did this before, but we'll create on this. We also want to keep track of our current health points. Magic points, you could do this same as well. You just also want to, check current magic points on that. Strength, we can use this to impact player physical damage typically in most RPGs. Agility could do various things. We can use it to impact player speed or something like that. Or maybe if you have a stamina bar, you could do that. And then intellect in most games typically can impact the player magic damage if you had like a mage class or something. You can define these to do whatever you want. They're not like, this is just some ideas, but we'll create a few stats on our stats component, and then we'll set up the curve table. So what is a curve table? Well, it allows us to implement multiple XY parameters through a common table asset. It literally just is like a Excel spreadsheet. Matter of fact, you can import or export as CSV or JSON file. We'll use this. We'll use an Excel file to do this. Matter of fact, I forget to send that to myself. Yes. All right. And then, as you can see, we could have all of our different values, and then they can have different values for each level. So let's go ahead and I'm just going to quickly download that from my other laptop. Download it. And we can see here, I just created this that can do some function based upon like some values that we pass in, and then like a multiplier. So we get all of these basically values all the way up to the top. So when we're at 30, level 30, our HP should be about 9,800. MP should be about 1,500. Strength, stamina, or what is this? Agility and intellect. So just to show you, and then I'm going to save this as browse. I'll save it here. I'm going to save it as a CSV file so that we can implement it into our game. So save as player stats table, CSV, save. And then as the CSV, I'm just going to delete these calculations. Let's, that should not have worked. There we go. So we have just the values. All right. Now I can close that. Let's go back to our Unreal Engine, and here in my components, I'm going to create a new variable type, and it is going to be of type data table, curve table, curve table. And linear, create curve table, player stats. And I can import from a source file, find that player stats, and then boom, look at that. Got some stats. And we can see, you can click on one of these and look at the curve of that value. So this one's pretty linear. They all look fairly linear. I think the health points is the only one that has like a somewhat noticeable curve. So here we could see that at time of 2, so this one's like kind of, you have to think of it as the reverse, the way that I set it up. So at level 2, our health should be 351. At level 3, our health should be 579. And then at level 30, 9838. So just like we said before. So essentially now we have this table that we can use to determine where the player's stats should be at any given level. So now that we have that, let's create our new component. So I'm going to create a new player class. It's going to be an actor component, and I'm going to call this player stats component. Create class. It's going to do some my build. And everything's good there. So let's close out Unreal Engine and let's go to our new component that we just made, player stats component. I like to have, I'm like so neurotic, I like to have the header and then the CSV. So what did we need for this? So we need to declare our stats, our individual stats. Then we need to declare a function called gainStat, and then we'll set up the onLevelUp delegate, and we'll do that in both. So let's start by declaring some of these stats. uProperty let's declare an int 32 health points int 32 current health points int 32 magic points int 32 current magic points. uProperty, let's declare int 32 strength int 32 agility intelligence. Perfect. And then we need our final variable, and it's going to hold that curve table. So it's going to be a t object pointer curve table player stats table. And remember that when we declare this as a t object pointer, we don't need to declare the we don't need to point to the header file. So here, when we declared this curve float, we had to put the header file here so that it knows where to find that information. We need to declare it as a t object pointer. We don't need to declare it in the header file. It basically tells it where to look. So now that we've got all those set up, let's declare our function. All right, and I'm actually, so we had that function that we wanted to declare gain stat. I played around with this for a long time, and what I actually found is that it was easier to do that in blueprints. When I tried to do it in C++, I had a lot of issues with it. So I actually want to declare that as a blueprint function. Think. Yeah. All right. So let's go ahead and save all this. And then I'm going to build it. I'll make sure we don't have any issues. Did I declare? Cool. All right, no issues. Let's open up our project. do have to, again, I told you guys in the beginning of the stream, I'm not as comfortable in C++. This is a flaw of my own that I've just became way too used to doing things in blueprints. So I created all of this ahead of time just to make sure that I could like have something to follow along with. And then now, and you didn't have to watch me struggle, but now so if I'm looking to my left, that's what I'm doing. I'm looking at the other thing. So let's open up our player character, and then we'll go to this, we want to add the player stats. And we want to set this curve table to player stats right off the bat. That way it's not null. And I want to, basically I want to create the ability to set my stats based upon the level that I currently am. So let's, I want to create a new function. I'm going to make this in blueprints. I'm going to call this set player stats. And I want to have this have an input of an integer, and I want to be able to pass in a level. So if we pass in a level, I want to set the stats based upon that. Then get player stats table, get row, get row. So we can pass in get data table row names. And I want to do a sequence because we're going to have to do this for each of them. So I want to all right. I'm getting it. I promise. All right. So I want to get this player stats table and evaluate curve table row. And the row name, I want to be able to pass in a row name to this. So what I actually want to do now is collapse all of this into a new function called get stat value. And this is going to return an integer, so it's going to be called stat, and this is going to be level, and we also want a name stat name. plug this in. All right, let's talk through what we're doing here. So we want to be able to set up all of our stats for our when we level up. We want to be able to look and see, based upon the level, what should each stat be based upon its value in this curve table. So if we pass in the level, we want to get back the stat, and that's essentially what this is doing. We're going to pass in the name of the stat and the current level, and we're going to get back what that stat should be, and then we can set that. So if we go to, like, let's do the first one was health points. So if we pass in the name of health points and the stat, then we should get back set health points, and we can set that value as our health points value. And then for these, we're also going to set current health points. The next stat, so let's just copy this down. This one's going to be magic points, is what we called it, I think. Yep. And then we can copy this, set magic points. You could probably do all this in C++. I just had some issues getting it to work in C++, and I just honestly ran out of time. Set current magic points. Let's add 3 more, right? I think there's 5 total. This one will be strength. And we don't need anything else there. This one will be agility. The last one was what? Intelligence? All right, so now essentially what we should have is the ability to pass in to this function, get player stats, a level, or set player stats. We can pass in a level, and then it's going to go to that data table. It's going to look for the stat name and return the value of that stat based upon the level that we pass in, and then we can set each of those stats. I do want to do a print string here just to check myself. Error stat not found. All right. And then here we want to set player stats, get our leveling, get current level, pass that in. So that right off the bat, whatever level we're at, all those stats should be set up. We can do some, let's just create some text boxes just to show this. This one's going to be bound to player stats, strength, player stats, agility, player stats, intellect. 10. All right. Intellect was 0. Stat not found. Intelligence. 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 Intellect. There we go. Perfect. All right, now we want to also create that binding. So let's save all. I want to create this delegate. So we talked about delegates in a previous lesson, but I don't think we ever actually did one. So it's a little weird. But on our leveling component, we actually want to declare that delegate. And the way we declare this is up here above the U class. I'm going to type declare dynamic multi-class delegate. I'm going to type F on level up. FK. Declare dynamic multi-class delegate. Let's give it a second. Declare dynamic multi-class delegate. And then down here, blueprint property off on level up. it's like it knows that it's what I want, but it's still giving me an error. So F on level up. F on level up. Declare dynamic multi-class delegate. Did I spell everything right? Multicast. There we go. Declare dynamic multicast delegate F on level up, and then we declare it as a property down here, F on level up. Let's try to build this. See what happens. It worked. I don't know what those squigglies are for. Declares. All right. Not really sure what's going on there. Let's just open it and see if we can access it. It built it. Had no compile errors. Just don't know what's the squigglies about. Oh, there's one thing I forgot to do, but let's just see if we can get this to work first. Leveling bind event to on level up. So remember, this is exactly how an event dispatcher looks, and then we can custom event on level up. So then on level, so then every time we level, we will reset our stats. But we did need to do one more thing. I'm just gonna say compile, save all, and then in our leveling component, when we level up, right? We need to do on level up dot broadcast. So this is going to, so when we level up, we want to send the message out into the world. That's what this broadcast does. Save. Let's see if we can get the hot compile to work. Should work. Yeah, perfect. So when we level up, in our leveling component, we're going to broadcast that message, and then here we're going to set up a listener to listen for that message, and when we hear the message, we're going to reset all of our player stats. So now these are updating to the appropriate stat based upon the level that we have. Hola, ¿cómo estás? Muy bien. Hablo un poquito español. All right, there we are. There's our stats. And if we look, when we got to level 30, our max strength was 592, which if we look here, 592, our max agility was 421, and our max intellect is 416. And if we were to set this up to be player stats, get player, nope, stats, health points, get current health points, get health points. Now our health points are also going up. So you could then use this to set up like a HP bar. So there we go. Our health component, our stats component is working. And it's working based upon our level. Everything's working. We set up some stuff. So hopefully in these couple quick little components that we built, you could see kind of the power of how C++, writing some of these things in C++, and then implementing them in the blueprints and leaning on the power of blueprints when things like this right here I tried to do in C++, and I'm not going to sit here and say you can't. It's probably easier than I'm making it, but I had a really hard time doing this in C++, and honestly I just ran out of time. I've been getting ready for this for a while, and I like built a buffer when I started week 1 of the course. I was like through week 5 or 6 at that point, and I was like, oh, I'll write 7 and 8 like as I get to it, and just ate away at that buffer until last week when I was just like, all right, I've ran out of time. We got to get this done. So the goal for week 7 was to learn about a little bit more about C++, a little bit more about blueprints, see how they can work together. Really, it's just like, ultimately it's up to you. It's up to the project. So when we go back to like those tips that we talked about in the beginning, right? These tips for like when you should use C++, when you should use blueprints. It really, as you can see, I just did things that I thought worked. You can do things differently. You don't have to do things like I did. There's probably a better way, but hopefully I've kind of made my point that really the power of them is using them to work together, and just do what's best for you, do what's best for the team, what's best for the project. Don't reinvent systems that are already in place, and challenge yourself. At the end of the day, that's what it's all about. So at this point, that's like the end of week 7. So normally, if I was doing things the way I intended to do, I would have spent some more time building out some of these systems, getting the project working, doing a lot more of that stuff. If we have time at the end of the stream, we can go back and work on some of those projects some more. But right now, I think what I actually want to do is just transition into the lessons for week 8. And I'll try to put a time marker for when week 8 starts. But I'm going to do a swap over, close out all this stuff. I still have some stuff on my old project. Hang on a second. Try to escape. Yesterday. Fire escape. All right. Let's give this a second. and I'll start on week 8. So I think I need to get a time marker, but 2 hours. I actually thought that those first couple of lessons were going to take me about 2 hours. So I'm getting better at estimating the amount of time things take, which if I had known that starting this course, I wouldn't be in this boat where some weeks took 7 hours and some weeks took 2. So, all right. So in week 8, really what we're going to be talking about is that the idea of, let's go back here. The idea of like launching your game. So we just finished the content for week 7, learning a little bit more about blueprints in C++. Week 8 is really about launching your game. So we've learned all this, you've built your games, you've built your prototypes. Like now it's time to release them to the public, right? You don't want to have to like distribute the entire Unreal Engine file every time. If you want to launch it on a certain platform, you're going to need to be able to get it to meet those requirements. So week 8 is about launching. So the first step of launching your game is optimization. So let's talk about some of the features of optimization, and then we're going to talk about some console commands. But when we talk about optimization, the question often is asked, like, when should I start optimizing? You can do it as you go. There's nothing stopping you. If you know, like, things are bogging down the game, definitely, like, be doing it as you go. But, like, for the vast majority of these things, it's something you're going to want to wait until the end. Like, if you spend too much time optimizing as you go, you may end up changing things anyways, and then you end up just wasting a lot of downtime optimizing. But that being said, I think you should constantly be like trying to iterate the project, making it better as you go. When we talk about optimization, we're talking about like really getting into the fine details of launching your project. And so I want to show you some tips for this. Now, full disclosure, a lot of these I got from other content creators. So these aren't like my own personal ideas. These are ideas that are generally agreed upon. They're just little tips on how to optimize various things in the game. And I'll show you some ways to do that. So those are in reverse order. So these are just a few things that we can do. Let's make sure that this is taking a while. These are just a few of the things that we can do for optimization. I need a folder. I need a game open. Let's just open up this one. Why are there 2 of these? That's weird. Let's just open up this one then. So there's a lot of tools built into Unreal Engine that will help you to optimize things. We'll go through some of these. We'll click on through them. But one of the things I want to talk about is when we talk about optimization, we're talking about improving frame rates, improving the look and feel of the game, improving the player experience in general. So a lot of this is going to be like done through play testing. It's best to get feedback from multiple people for your play testing, but you could do a lot of like the quick stuff right off the bat. So one of the things I wanted to show was this statistics thing. So let's open up one of our levels here. And here we have a level, and it's loading the shaders. But if we go to, what was it? Tools, Audit, Statistics. And this pulls up a window for you. And I don't know why it's not letting me dock that. But in here, we can look at various stats for our game. So if we go here, primitive stats, we can see some various statistics on this. We talk about the size, so like the size of each of these assets. So this one's like, what's that, 4 megabytes. Nothing too big in here. There's other stats over here, texture stats. We can look here. This is the size of these textures that are taking up in memory, so not too bad here. This is the prototype game, so there wasn't a ton of stuff in there. But you can go through these stats and kind of just look at like what is taking the most memory, the size of your game. So when we build our game, it's going to create like an exe file, and that needs to be some platforms. Maybe you have a size limit. You want to get the game under 5 gigs or under 20 gigs or something like that. So this is going to tell you like how much space each of these is taking. And if we look, this gun is the one that's taking the most right now. If we look at our textures, you can see that textures are a lot bigger sizes typically. So like if we look at the size of this, these are 2K textures. This is a 1K texture. This one is a 1K, but this one's an interesting one. But this is 256 by 256. So you can see that like the textures take up a lot of space basically. What's going on here? I'm gonna keep an eye on this because I really actually wanted a different project, but I forgot to download it from my GitHub. So these are the statistics, and so this is good for if you're trying to get the size of the game down. You may also from time to time get this little thing up here that says like texture streaming pool over budget or something like that. You can do, if you type streaming down here, you can pull up a stat to change that texture pool size. I always have to Google it because I always forget what the stat is. But that's the first thing, those statistics. The second thing is the update texture streaming pool. So like I said, I think it's, if you type streaming, here we go, our texture streaming. Then you can type in a value. So by default, I think it's 1,000. But if we wanted to make it bigger, we could go like 3,000. And what this is it's telling us the max number of textures that could be loaded into, like the max cache, the max memory that we're allotting for textures. So if you have like an ultra realistic environments, you're probably going to get that error. You're going to want to update that texture streaming pool size. But you can also see, if you go to this audit, you could see in your textures like which ones are the biggest offenders, and maybe they don't need to be as big. Like typically these normals don't need to be big because this is just giving like some it makes the assets look better, but it's negligible on the normals. Really, like the diffuse textures, or sometimes they're called color, are the ones that you're going to want to pay more attention to. These _D, _M, I think is for metallic. These again don't need to be supersized, so you can actually I thought you could right click here and find it. If we go to like if we go to content and type concrete, we can see these texture files: normal, diffuse. This one's like a metallic map. So you can see it's like very basic looking, right? And this tells you it's a 512 by 512. So you can downsize these. Like this one is a 2K texture for normals. We probably don't need that. So you can actually open it and thought you could set the value somewhere. Anyway, so yeah, there's that. So that just gives you some ideas on how to shrink down the amount of memory that things are taking up, shrink down the size of the game. When you build it, you can downscale the textures. I thought I was doing that, but check LODs. So we haven't talked about LOD, but it's level of detail. So if I were to go into the starter content props, let's look at this chair or this table. When you have one of these open, if you notice, it has this auto LED thing set here, auto LED. And here we can see this auto LED picker. You can set custom, and then what this does is it basically, I'll try to explain it, but if I had a tree, let's say, and I was really up close to it, I would want that tree to look like pretty detailed, right? What is going on here? But as I move further and further away, I don't necessarily need as much detail because I'm not going to be able to like see all of the individual leaves. Now, if I had like a forest of thousands of trees, then if I'm trying to load in every single leaf on every single tree in an entire forest, it's gonna like kill my computer. So what Unreal Engine does is as things move farther away, this LOD is going to like decrease the detail automatically as we move further away. And you could see that this one only has one. So Unreal Engine is actually pretty good about like knowing how to select this, but you can change some of these as well. If you wanted to set up additional LODs, so this one only has one. If I set it to like 4 and apply, then where is it? We can see that. Oh, I think I also need to turn off this nanite. We can see here like this fallback triangle. So this has 1,000 show vertices. So as we like scroll in and out, it's basically removing some of the detail of this. So you can see how that would be very helpful if we had like a lot of these in a scene, right? So you can check all these LODs. You can set additional LOD channels. Something like this table you may not have hundreds of, but you never know. So check all of that in your assets. Again, you can when we're playing a game, you can look at all of this stuff. Hang on a second. Let's go back here. Freeze rendering. This one's actually pretty interesting. If we're playing our game and we hit tilde freeze rendering, actually it's better. So Unreal Engine is only ever going to render what is on the screen. So as I move close to this this building, it's rendering everything here, but like this, if I turn and look this way, it's gonna stop rendering that stuff. So we can use that freeze rendering. And then look, when I turn away, that building is no longer being rendered because I looked away from it. The flames, I don't know why that's still doing it, but like you can see how the shadows are still there, but they are actually not. And then if I do freeze, I can go back and then it's there. So you can look for things that are still being rendered even when you're not looking at them, like these fires were. I think that has to do something with the particle system, but I like to kind of look, so as I'm playing my game, check the frame rates and just see like, when do I have a frame rate drop? Like, what am I looking at? And then try to find ways that we can reduce, like in specific areas, what is being rendered and what is not. Yeah. So the freeze rendering is a good tool for finding like egregious offenders that are causing like dips in performance of your game. Disable lumen and nanite. In most cases, they're almost always going to be unnecessary, so we can do that in our project settings. If we search for nanite, you can disable that, and this is going to make you have to restart your game, and then do the same for lumen. Unless you're making like a crazy high realistic game, and even then, I would argue it would be like a crazy realistic game, but also using like super detailed assets with like millions of triangles. You're probably not going to need it, and in most cases you're just having extra stuff going on that you don't need. So I always disable it. Just disable nanite and lumen unless you know you need it. Used bake lighting, so I'll show you how to do that. And then check your collisions. So there's a thing for show collision once Unreal Engine loads back up. We disable nanite, so it's got to rebuild all my shaders. But you can use the show collision to see, like, collision is a little bit more expensive, and if you don't need like highly detailed collisions on your assets, you can just go with some simple colliders. I've even like in some situations like disabled collision on everything and then just built like boxes where I don't want the player to go. That's one way you could do it. All right, we're almost there. Perfect. Let's go to level 2. Another thing, these box brushes are kind of intense on the computer, so you want to get rid of all those. What were we talking about though? Oh, nanite and lumen. So let's do lumen now. Global illumination method, just use none. So global illumination method, just put none, and then reflection method, just use screen space. This will actually save you some performance as well. And you'll notice that like the game for the most part doesn't look much different. Am I still building shaders? What's going on here? Nanite is enabled but cannot render. How's this other project coming along? All right, let's close this one. I want my other one. I've done a lot more work on this one. That's why I want it. All right. So the last thing I want to talk about is these console commands. So these I use a lot when I'm building, like throughout building, but especially during optimization. These are definitely things that you want to be checking. So I'll show you basically how these work, but let's start our game. And if you type the tilde key, you'll get this little command window. Yeah, you can see it on the stream. And then you can type in some commands. So I can type stat FPS, for instance. And then notice on you can't really see it, but there on the right side of the screen, I can see my frames per second, and I'm sitting at like 35 frames per second. So if we wanted to get this up, we could look for like what is causing these frame rate drops. So there are some other stats that we can use. For instance, stat game. Let's type tilde stat game. And we can see here, this is giving us some information on like what is taking, like what things are on tick basically. And we can see not too bad. We're only adding like 40 milliseconds. What is it? Like a couple milliseconds in tick. So if we type stat game again, we'll get rid of it. The next one, stat engine. So stat engine. This gives us some more information about our frame rate. We can see here like some information about what is like the number of triangles that we're rendering at any time. We can look around and see if we see any jumps. So notice, let's do the freeze rendering. And let's look. So now none of that stuff is rendering anymore. And we can see, yeah, that. So let's press play again. Stat engine to get rid of that. And the last one, stat GPU. So we can do stat GPU. See some stats upon like what things are being rendered by the GPU. So we can see lighting is a big one. Lumen, again, if we disable lumen, all that basically goes away. So lighting and lumen. So if we get rid of lumen, shadow depth, so we can disable we can disable, we can make everything have a static shadow that doesn't need to be having a moving shadow or a dynamic shadow. And then stat memory. We can see what things are taking up some RAM, so we can see that texture streaming pool is a maxed out, or texture streaming pool is the max, and we're using 200 megabytes of it. If we go to like a different level, so let's go to like I built some other levels that are a little bit more. Let's do level 3. Level 3 is slow. It's a big level, that's why. It's going to take a while to compile these shaders. 57. All right, what was it? Stat, GPU, stat memory. Let's press play, see what we get. So here we can see we're using a little bit more of that memory, like 400. Get this. So our frame rates are pretty bad in this level. Base pass. So yeah, so we're at like 10 stat GPU stat memory. So we can look around and see like where's those frame rates dropping, where they get better. Like if I look over here, notice they go up to like 50-ish. But as I look into this world, they start to drop almost immediately. So to like 15. So we can do some things to try to improve that. Some of the tips that I gave you. So yeah. But basically, you just want to try to look through some of the ways, some of the things that are causing performance drops in your game, and really try to use these tools: stat FPS, stat game, stat engine, stat GPU, stat memory, and then these ones here for these statistics. So like in this one, for instance, this is a much bigger game. So if we go to tools, audit, statistics, we can see that we have like texture stats. Like look at all these textures that we have that are 2K, 4K textures. So we don't necessarily need those to be that big. We can downsize a lot of these, right, to be smaller textures. I can't remember how to do that specifically, but you could probably Google it, look it up pretty quickly. So that's all that stuff. When we look at primitive stats, that gun seems to take up a lot of space. I don't know why it won't. So that gun is 11 megabytes. Or no, this paper. Oh, the gun, this shelf, so we can add these racks. So we can see like what things are causing the size of our game to be taken when we build it. If we wanted to like go to a minimum, like to reduce the size. So like here, look, this is that texture streaming pool. So like the total allocated memory is 466 megabytes. So we would never hit that streaming pool in this level, basically, is my understanding. But yeah. So again, these are all just tools. Oh, here we go. This is that one. So this rack has 7,600 triangles. We can try to reduce that by setting up some LODs for it. So we can set up number of LODs 5. So let's, yeah. So see, as we go out, the triangles are going down. That's those LODs at work. 10,000 when we're up close. So yeah. Anyway, that's the point. Optimization. These are all just checks that you can do before you do that first build of your game to try to reduce the size, to try to improve the frame rate, improve the performance of your game, and then you want to build it. So that brings me to my next lesson. Which is packaging a project. So you've done some optimization, you've got everything working, you've done some basic bug checks, and you want to basically create a way that other people can play your project. Maybe you want to do some beta testing or even some alpha testing. Maybe you just want to give it to a couple of your friends and have them try it out, see what they think, get some early feedback. Or maybe you're at the point where you're ready to launch your game onto Steam or the Epic Store or itch. You want to show the game to the public. So these are the steps of packaging your project. So we're going to talk about build checks. We're going to describe the packaging process, and then we'll perform these. So build checks allow you to fine-tune the look and feel of your game before you package your project for distribution. So the goal is to maximize the player experience with these build checks. And it could be a different thing, but in Unreal Engine, this means your code is compiled to include all the changes, your lighting is set up correctly, and there's a lot of other things. If you're using Nanite, if you're using nav meshes, if you're using landscaping tools, you can build all of these things. So let's go through some build checks for our game here. So if you go up to the top, let's get the bigger view. There's this build, and then you see that we have all these different options, and they kind of correspond to some of the things that I said. So we can build geometry. It's going to build off the meshes and collisions. You can build collisions, I think is one of them. You can build landscape if you're using landscape. You can build lighting. So you can also build lighting based upon a variety of settings. So production would be we're ready to ship, high, medium, preview. If you've ever gotten this lighting needs to be rebuilt, then that's telling you that you need to just go to this and say build lighting only. There's also this build all levels, which if we scroll over it, it's going to build out kind of a lot of different things. So this does take a while, and especially if you have like a lot of levels and a lot of detailed levels, it's going to take a while. Like I've even had it take like a day, honestly. So one of the things I always say before you start one of these builds, make sure you save everything, make sure you back it up to your source control. Really make sure that you are ready for this build, because it's going to take a while. Make sure you turn off like your sleep mode on your PC so it doesn't go to sleep halfway through it and ruin everything. Yeah. One thing also to note is that when you build the game, all of the levels get built with it. So I have all these like third-party things. For instance, this storage house here that I've used for one of my levels. If I go to that package and I go to the map, I can see that we have like these levels in here, and these aren't small, 9 megabytes. If I go to another one, modern city environment, maps, 12 megabytes, 20 megabytes. So I also recommend that if you're using a lot of like third-party packs, before you package your game, again, make sure you're backed up to source control. I also like to, like if I'm going to do a build in my repository, I like to create a new branch called like the build number, and you can create up your own like system for this. Some people like to use the date. Some people like to use like build 1.0. 25, I don't know. And then create a branch, and then just leave that branch for that build, and then you can always like revert back to a build or like see like what was working in a specific build. I think I just broke it, but switch branch. So then you can like create your build here. and then there's like a snapshot, but like in this build, maybe I want to go through and delete all of these maps that I'm not going to be using, so they're not built with the game, right? So that's one of the things you can do. So just to show, like, I don't know how long this is going to take. We can try it, and then we'll talk about the next thing. And if it doesn't finish, then we can stop it. So build lighting. It's going to set up some stuff. I promise everything's fine. Microsoft. Reduce. Yeah, I would say you definitely want to well, first of all, the plugins are, I can show you that. Let's go here. Is it in this one? Config. So when you, this is the, I'll show you how this works. So your U project, if you right click, you can open it in Notepad. I have Notepad++ just because I like the looks of it a little bit better. You can actually look and see the, can I scroll this in? Yeah. You can see the engine it's associated with. So this one is built for 5.4. That's why in my editor, when I look at it, it says 5.4 next to it. If I change this to another version, then in my Unreal editor, it's going to tell me that it wants to open with that one. But you can also see here plugins, and yeah, if you're not using these, you can just get rid of them. Like this one we're not using. This is a type of file called a JSON file. It kind of looks like a programming file, but it basically just, it's like a data file that different programs know how to read this data. So you could like delete all of this, I think, but I don't think it's really hurting anything. This one probably doesn't take a lot of space, but something you definitely want to check, like before you build, look in your plugins, see which ones that you're sending with it. So that's good. You can see that my building is already at 0%, so we can see that's going quickly. So yeah, that's a good check. I like that one. But yeah, like I said, if you are using Nanite, you can build your Nanite, you can build your landscapes. All these are just kind of some pre-builds. I'm actually going to cancel this because it's going to take forever, and I don't want to wait forever. I want to keep this lesson moving because we are getting close. So then the last step. So you've done the optimization, you've done all those builds, you're ready. You want to ship this project. So then we want to package it. And packaging formats the project into a distributable file. That basically you can send to your friends, you can put it on itch, you can put it on Steam, and it basically is just an executable file. Someone doesn't need Unreal Engine to play the game. Multiple platforms are available by default. And we'll show that. There's multiple configurations available. So remember we talked about those console commands. You can actually ship it, and you can, so that the person can still use those console commands, and that would be like the development or the debug configuration. Shipping configuration will actually disable all of that, so people can't hack into your game through console commands. Like there's a console command called open level. Someone could, in theory, like use open level to go to the final boss and just kill the boss, and look, I beat your game in 3 minutes, you know. So the shipping build will disable that. But if you are going to distribute this to like some playtesters and you want them to have access to those commands, you could ship it in a way that they could still test out the game. You could even give them a list of commands if you wanted like the stat FPS so they could check their frame rates, things like that. Cooking, it's kind of like packaging, but without creating the package. So when you package your game, it's going to like go through every single thing in the project, and we'll do it. So I'll show you. It takes a while, but it's going to go through like every single file in the project and basically see like, get it ready to go. Cooking does that without building the package. So I can show you that. If we go to here to platforms, so this is where we would ship it, where we would go to ship, and we can say enable cooking on the fly. That's interesting. Never noticed that. But here we can go to, we want to create a Windows executable. So we can either go to package content or cook content. Cooking will prepare it for packaging without actually creating the package. This is interesting. I wonder when that got implemented. I've never seen that before, but we could do that. And then here you could see that we have those different configurations. So debug game, development, these will still give access to some of those functions for your playtesters. There's not a ton of information on the difference between these. So notice that development is the default one. We could just leave it there, or we can get it ready as a shipping build. So if I select development and then, I'm just going to use whatever it was, development. And then if I say package project, it's going to ask me where I want to put this. So I'll just put it on my desktop, and then it's going to start the build. Yeah, I want to allow access. I trust this. Now we can do this show output log, and I like to make this full screen when I'm doing a build. Why won't you let me? And you can actually go you can actually watch what it's doing. So here we already got some issues. It's giving me some warnings. Intended asset will fail. It's going to do some nonsense that you can't really read. So yeah, sometimes I like to read this. This is going to give you a list of everything that it's doing. And depending on the size of your game, this could take a while. It's going to build all the textures. It's going to build all of the static meshes. It's going to build everything, get it ready into a package that you can ship out. So we're going to leave that going. We'll come back to it when it finishes. The good news is if you're like having it going in the background, it sends you like an audible message when it's done. There's two different, one is for good and one is for bad, and they very much sound that way. So yeah. Let's go though to the last lesson. Oh, second to last lesson. There's one more after this. Releasing your game. So you have a build, you had some playtesters, they said everything's perfect. You're the first developer in video game history to make a perfect game. There was no bugs. This thing's ready to go, and you want to release it. You want to release it to the masses, and yeah, whether this is for a portfolio or you want to release it on Steam, we're ready to go. So let's talk through this. So we're going to describe some popular methods for releasing products, and then we'll talk about common requirements. So this should be of no mystery to anyone, but Steam, arguably the biggest PC games market out there. There's over 50,000 games on Steam. It's actually kind of crazy when you look at it. It's getting to the point where it's like hard to find a game that hasn't been made on there. But this is very common for PC developers, for PC gamers, pretty common for indie devs because the requirements are pretty low. Last time I released a game on Steam, it was like $100 to buy the Steam page. And then they take a percentage of your sales. I can't remember what it is. It's like 20 or 30%. I can't remember. But hey, if you're selling your game, I look at it as like, sure, you can take a chunk for making it easy for people to get to. So Steam is definitely the most popular. There are some requirements for Steam that are pretty common across all these platforms. Epic Store, there's around 2,000 games last time I checked on the Epic Store. So it is growing. And this is mostly because Epic is trying to get more and more people to use their platform over Steam. So they're offering incentives to Unreal Engine developers. So right now they do offer some incentives, especially if it's your first game. I think it's like 6 months or a year, 6 months to 12 months, somewhere in there, that they don't take any cut. Like the first 6 months is on the market, you just get 100% of the profit. Especially if you launch it exclusively on Epic, like you basically tell Epic, I promise not to put this game on Steam or anywhere else. They'll even give you more of the profits from that. So these platforms are great because they have a wide audience of people looking for games. If you're just trying to get your game out there, these are typically like some of the best places because you probably will get noticed. It's pretty common. Most people use one or both of these already for playing games, so you're not asking someone to download some other crazy third party. And also one of the benefits of these is that they do have some like security in place. So like when you launch a game to Steam or Epic, in my experience, there's been some checks where they basically just make sure that the game is not malicious and like stealing people's data. So another reason is I think a lot of people, will trust a game that's on Steam versus just, hey, go get it from my website, or here's the thumb drive, play my game, So yeah. Mobile games, big growing market. I think it's like 80% of the revenue comes from mobile games and like the entire gaming industry. It's absolutely insane. So if you want to launch your mobile game, Android for non-Apple, and then Apple for Apple, or both, these pretty much have the same requirements as Steam and the Epic Store. In my experience, Apple was a little bit more stringent, and there's like more of a waiting time with Apple. So just plan accordingly. I recommend if you're like 6 months out from launch, you probably should just go start setting up all these stores, because there are sometimes some like waiting requirements as well. So you don't want to say like, I'm going to launch this September 1st and then wait till August 31st to start getting all this stuff set up. You're not going to make that September 1st launch. So I would say like 3 months, maybe up to 6 months, start setting up your page, get everything on there, ready to go. Itch.io, this is very common platform for indie devs. It's a great place to get your games out there. This is where like a lot of game jams are hosted through. One of the benefits of Itch, you still have a pretty broad audience of people going on there and looking, especially people that are looking for indie games. And it's free to host your game there. They don't, my experience, do any like checks when you put a game on there, but you can report a game that's malicious and they'll have it taken down. So yeah. And then consoles. So this is like your PlayStations, your Xboxes, your Nintendos. These are typically the most restrictive. I know specifically like the Nintendo Switch is like super restrictive of who they let put a game on there. So if you want to launch a game to console, I recommend start doing some research. I've never launched a console game, so I can't tell you everything that goes into it, but I do know from people I talk to in the industry, it is significantly harder to launch a console game. So if this is the way you want to go, I recommend do some research, and I would give yourself even like 12 months before launch to make sure you start getting all the ducks in a row for launch. So this is some ways you can distribute. You can also just post on your own personal website. These are just some common ways to get the games out there that people use. So some common release requirements. You're going to need a packaged version of your game. That's what we're making right here. We're making that packaged version so we can distribute this game. We are going to need some media. So every every platform that I've launched on, which would be Steam, Apple Store, Itch, they're going to want some basic marketing materials. So this typically means like a gameplay trailer is probably something you're going to want. Steam, it's actually a requirement. There needs to be at least one video showing gameplay of your game. And the gameplay does need to be from your game. Other gameplay videos, like a teaser trailer, screenshots, you have to have, for Steam, I think you have to have minimum 6 screenshots. That might have changed, but you can look up all the requirements. So you're gonna need screenshots, videos, you need a synopsis. So what is your game about? What is the information of it? ESRB, this is based upon region, so it might not be called ESRB in your country, but basically like the age requirements to play this game. This is where you're going to need to understand like who's your target audience. If you violate these, so if you say this game is for kids and someone downloads it and it is clearly not for kids, they will take your game off immediately, and that's the end of that. You've violated the terms. So I recommend, if you're going to have anything that is not like absolutely PG or even G for your game, do some research to figure out what classification you need to label at, so that you know that you're not releasing it to the wrong audience. And it's going to depend upon each country, so you may want to understand like what countries you're going to launch your game to, and then so like I know some countries have more restrictions, like where you actually can't launch a game if it has certain content in it. So do some research. Typically it's safe if you say like Europe and the US, or like Europe and North America, you can get away with most stuff. You still need to understand the age requirements though. And then system requirements. So what system should this run on? If it's a PC game, what are the minimum hardware that people need to have? There are some websites that can help you with this, but what I typically recommend is like I have an old crappy laptop that I try games on just to see if it works. And if it does, then I say it works on anything. But you need to at least like put some basic requirements. You can also Google it and it'll tell you like some recommendations based upon like current platforms. So these are just things you need to consider before you launch your game. All right. And that's that lesson. So let's check on our build. Still moving along nicely. It is, so it actually gives me some information. So 3308 packages remain or have been packaged, total 5,000. So okay, we got lots of yellow. The yellow is not necessarily bad. These are usually fine. It's just giving you like a warning, like, hey, just so you know. But it looks like we're like 80% done ish. So we'll just let that keep going. We can go to the last lesson. And hopefully the build is done by the end of this one. Course recap. So we have reached the end of the content. This is it. Not too bad. We can spend some extra time after the build's done if it's still not done by the end of this. And we'll just clean up some stuff for our games. But we've done a lot in 8 weeks. If you've been following along the whole time, it's been, I think last time I checked, it was like well over 20 hours of learning already. So this will put us, if you were to start it, it might take you a whole day to get through it, start to finish. But anyway, hopefully you didn't try to do it all in one sitting. So this is what we've covered each of those weeks. So in week 1, we talked about the basics of a game engine. We started on our project Fire Escape. We built some of the basic functionality, getting the player to move around, things like that. In week 2, we completed our game loops. So we were able to put out fires. We were able to die in a fire. We were able to run out of time. So we built the winning conditions of our game and the losing conditions. Just keep in mind, not every game has both. Some games only have a win condition. Some games only have a lose condition. Some games have both. So really what we're talking about there is we want to define our game loop and then build the game loop that we want. Week 3, we started on our alien defense project. We learned a little bit about object-oriented programming and what that means. We learned about the 4 principles of object-oriented programming, which are encapsulation, abstraction, polymorphism, and inheritance. So a lot going on there. Oh, thank you so much. I have honestly learned a lot doing this. I enjoy doing these courses, so I appreciate the feedback. And I'm always looking for ways I can improve it too. So feel free in the comments or on my Discord, give me the feedback. I always want to make it better. I want to make content that people want. So yeah, definitely I appreciate all the positive vibes, but some negative vibes or some personal improvement vibes would be good too. I already know that the course feels rushed, so you could beat that drum some more, but I know it feels a little rushed. In week 4, we continued working on our alien defense project. We set up an inventory system, and to do that we learned about structures and data tables. I would like to do some more streams in the future where we finish these projects, so we kind of left everything like half done. So I think I'll do some future streams outside of the course that continue to build upon these, and I'll make sure to put some info out on my social medias and on the Discord about that. Week 5, we learned about source control. So this is a way that you can share, you can collaborate with others on the same project. It's a question I see almost every week on Reddit. Like, hey, how do I work together on the same game as my friend? Source control. Hey, how do I create like a backup of my project? Source control. Like if you spend an hour on a game and you're like, hey, this is going somewhere, I want to keep working on it, put it on source control. Like it's just a no-brainer to me. Like you should always have your stuff on source control. If I'm just tinkering with something, no. But if it's like, if I start building a game and it's working, it just almost immediately goes on source control. Week 6, we learned about C++. We started working more on our action RPG project. Really just kind of scratched the surface of C++. There's a ton left to learn there. I'm not an expert by any means, so definitely gave you some resources to continue learning C++, and we'll talk about more of those in a couple slides. Blueprints of C++ we did earlier today, so we talked about how they work together. To the question, which one should I use? The answer is almost always both, but the answer is almost always it depends as well. So it really just comes down to the needs of your project, the needs of your team, the skill level of your team, and the timeline. Like if I'm doing a rapid prototype, I'm not even going to touch C++. I'm just going to prototype it, get it working, ship it. So, and then we talked about launching our game. You know, what are some things that you can do to optimize it, some things you should be doing before you build it, how to build it, and then how to distribute it. So RPG course, RTS course would be cool. Like what type of RTS? I'm interested. Are you talking about like old school, like Warcraft, StarCraft? Anyway, one direction you want to go. Maybe you're more into like building systems and you want to be like person that just builds like inventory components and stat components and leveling components for your games. Maybe you don't care so much about getting in the details. You want to be a game designer. You just want to make cool levels and cool systems and make the funness of the game. Maybe you liked doing like level design and you were more interested in like the landscaping tools and like all of those things. Maybe you liked the materials, building like those types of things, setting up animation state machines, things like that. For those, you know, tech art is probably a good path for you. Warcrafty, yeah, that's a good idea. I'm gonna keep that. I'm gonna write a note to myself. Look, I'm literally writing it down because I'm not young. I still write things down. All right, how to make Warcraft. That's my next project. All right, so But in this course, we also really just made some prototypes. So none of the games we made are ready for release. Even the one that I spent several more hours on building out some extra stuff that we're building, there's a ton left that we could be doing, right? So if you're finishing this course and you're like, what do I do now? I would recommend complete the first 3 projects. Get them ready for release, get them ready for the public, spend some extra time building out some levels, building in some new features. Again, we don't want like 100 carbon copies of the same 3 projects I made. So we made the Fire Escape game, the Alien Defense game, and the Action RPG game. Make each of those games your own. Make it something different. Take some of the lessons you learned from later on and put some of those into Fire Escape, or just put your own spin on them. Continue developing these. My recommendation is to have those 3 projects to be kind of like the foundation for a portfolio. So if you create those 3 projects, you build out like a demo of them, put them on an itch page. Now you have a portfolio that you can send to, if you wanted to get into game dev as a career, you can use those for your resume to say, hey, I have these 3 portfolio projects. If you want to collaborate with people on projects, a lot of times they're like, do you know what you're doing? You can say, yeah, look, I made these three games. So definitely like spend some time on those 3 games, put them somewhere that people can play them. And that's really a foundation for your portfolio. Maybe one of the games that we made you liked more than the others. So maybe you're like, this Fire Escape game is right up my alley. I love, first person puzzle shooters like Portal. And I could probably think of more, but I won't. And you just say like, hey, I want to make a complete game of this, and I want to put it on Steam, or I want to put a lot more time into it. You can maybe take one of those and just build a lot more out in it. I do recommend you continue to build your skills. So we really just scratched the surface on a lot of topics. I typically like to warn people. There's a lot of noise out there. There's a lot of people that say, you could learn how to make a game, just follow my course. And there's a lot of people who they don't give the best advice. I'm just going to be honest. And I'm not going to name those people. But what I will do is try to think, because I don't want to rag on other developers, right? People are taking time out of their day. They're trying to make courses. They're trying to make the world a better place. I think sometimes they just don't give the best information. So here's some places where you can get good information, typically. Stephen Ulibarri, he's got a YouTube channel. I'll go find it if you don't already know it. Druid Mechanics is the name. This guy. Druid Mechanics, look him up. He's got a lot of tutorials on here about some stuff. This guy, one of my first mentors, kind of put it perfectly. There's a lot of people who are game developers that are teaching programming. Stephen Ulibarri is a programmer who's teaching game development. This guy understands C++ and Unreal Engine at a level just most people don't. I will say that he's not for everyone. Steven goes insanely in detail, like to the point where a lot of people just like don't even ever finish his courses because there's so much detail. His courses are like 80, 90, 100 hours long, right? And if you consider that's not like, it's not going to take you 100 hours. It's going to take you like 300 to 400 hours because you're going to have to watch it and then do it. So it takes like 2 to 3 times as long typically. So if you see an hour course, typically I give myself 4 hours to get through it, because that's about how much time to watch it, comprehend it, understand it, and then implement it. So he's great, but if you're not looking for someone that goes so much in detail, he might not be the best for you. I still recommend at least check out one of his courses. He has a Intro to C++ on Udemy. Let's look it up. Stephen Ulibarri, Udemy. So yeah, he's got this one, Ultimate Game Developer Course. This is really good if you want to learn some more C++. If If you want to learn about the gas system, this one's great too. Again, really in detail, but good. If you want to learn about multiplayer games, this one's great as well. It's a little bit dated, I would say at this point, but not so outdated that you couldn't still learn it. You're just going to need to get Unreal Engine 5.0. It doesn't. I don't think it actually works on Unreal Engine 5.4. Whatever version he uses, that's the one you're going to need. This one is actually game development with C++, but not using Unreal Engine. So I actually recommend this one usually if people are going to, or no, it's this one. Yeah, one of these two. I can't remember which one. This one is pretty cool. Again, a little bit dated. I think this one's 4.25 or something like that. It's a little bit dated, but still really good. I would argue this one, the multiplayer course, teaches a lot of the same stuff. This first-person shooter, this is a blueprints course. So if you're just like, I hate C++, this is a good one for a first-person game. This one as well. This course, Git. So we talked a little bit about source control. If you really want to understand source control, this one's great. Yeah, I recommend all of his courses. These are great courses. But again, these are not free. They're paid courses. He on his Discord, he gives out coupons from time to time, about once a month. So join his Discord. You can check out when he I think he usually does it around the beginning of the month. So yeah, there's that. All right, the next person, Tom Lumen. I'm actually just going to go to Tom's website. Tom Lumen. This guy's great. Again, really knowledgeable person, giving excellent advice. Absolutely excellent. He has a lot of stuff for free on here that you can just go through. Game optimization, gameplay tags. So these are all like free. Like, it's pretty awesome. He does have a Udemy course, or it's a paid course. Yeah, so you can see here, it's not free, but he has a lot of free stuff on his website that you can just go check out. This guy's great. Honestly, either one of these, Stephen Ulibarri or Tom Lumen, or do both. Check them both out. They're both great. GameDev.tv. This one I usually recommend for beginners. If you want to learn about Unity or Godot, or maybe you're more interested in the art side, you want to learn Blender. They have a lot of courses, right? I'm not going to say anything bad about them, but I will say I find that these are great for beginners if you're just starting out, but there tends to be like a point where you'll reach where like these courses don't really provide value anymore. Like there's not really any advanced courses. They're not really like, there's some intermediate courses that teach like a little bit more complex things. You probably need some, like you couldn't just jump in as a beginner. They're going to be a little bit too complex for a beginner. They're more at like an intermediate level, but if you're looking to like really get advanced, there's just not much. And to be honest, there's not much out there other than like Stephen Ulibarri or Tom Lumen, or just reading the documentation yourself. So yeah. There's also some really good YouTube channels. The Unreal Engine YouTube channel is great for learning. So this YouTube Unreal Engine channel, they do these talks, I think every Thursday. They're always great. There's always a ton of information put in them. Really good stuff. Ryan Laley has a lot of good stuff. Code Like Me, he's another one I recommend. So definitely want to continue building your skills. Never stop learning. Like that's the number one key. Never stop learning. You don't want to ever get comfortable and be like, I'm good enough. Just constantly keep pushing yourself. Build those skills. Learn another game engine. Honestly, this is the advice that I give a lot. If you just learn Unreal Engine, I'm not going to sit here and say that that's a bad thing. You know game dev, you understand Unreal Engine, you can continue to learn C++, but you're kind of like pigeonholing yourself to only knowing one thing. And you're not really understanding like what things are specific to Unreal Engine and what things are just more general like game development ideas. So by learning another game engine, you create this ability to conceptualize things in like a very abstract way, and you're not thinking like, how would I do this in Unreal Engine? You're thinking, how would I program this game? And then I'm going to use Unreal Engine to do it. So what I always recommend is learn another game engine. Take a Unity course, take a Godot course. Raylib is another really fun one. There's a lot of stuff. It's free. The dude is absolutely incredible. He wrote this whole game engine, and just it's like free, and there's no like licensing ever. You could just do whatever you want with it. It's technically a library, not a game engine, but it's a very thin line between those two. So learn some other game engines, continue to build your skills, continue building your skills as a game dev and as a programmer. Join some communities. I do have a Discord. Oh man, it hasn't been showing. There's the thing. Join the Discord. There's other great communities out there. Each of these content creators have their own communities. Join them all, especially mine. But join some communities, meet some other game developers. Try to collaborate with other people too. I think a lot of people tend to like to work in a vacuum, or they like to think like, I'm going to make my game, and I'm going to find other people to work on my game with me. Sure, there's nothing wrong with that, but you actually will learn more trying to make other people's games, because they're going to tell you, this is what I want you to make, and then you have to figure out a way to make it. You're not the one coming up with the ideas anymore. You're trying to implement other people's ideas, and that will make you a better programmer. This is also why I recommend game jams. Game jams are great when you're starting to learn, because there is nothing to lose. You can join a game jam, and if you get 3 days into it and you're like, I hate this, just don't do it anymore. You can just be done with it. But game jams are a great way to challenge yourself, challenge your skills, find skill gaps, get good at working with teams. A lot of game jams allow like up to 5 people. Typically that's like the limit. So it gives you a chance to collaborate with other people, understand how to use source control better, find those flaws, find your own skill gaps, find things that maybe you enjoy doing more than others. It puts you in a high pressure environment, which is where you typically get really creative and really scrappy. So game jams, I recommend doing like 1 to 2 game jams a year. Just find 1 or 2 a year and do them. It will always bear fruit, I promise. So that's kind of where to go after this course. Hey, if you made it through the whole thing, I appreciate it. It's probably like close to 20 hours of coursework. That's just 20 hours of listening to me talk mostly. I appreciate all the support I've been getting. Join the Discord, like and subscribe. But honestly, I enjoy making these courses, and I hope people are still getting value from them. I always want to be doing better. I always want to find ways to do better. I got some feedback today. We're going to make a Warcraft clone next, so that'll be fun. That's something I've actually never done, I think. So that could be fun. It will be a solo. It's going to be a single player experience because multiplayer is a little bit too complex for right now. But that might be a really good thing that we can do in the next course. So yeah, thanks for watching. Thanks for sticking with the channel. Like, subscribe, do all that stuff. Check out the website where you can book a session with me for 60 minutes. We can talk about whatever you want. Check out the merch in the store. Buying that merch gives you something cool, and it also helps me a little bit, put some money in my bank account. So I appreciate all the support I've been getting, and I will see you all around.